All right, I'm Ben Stabler, Vice President of Mobility Products for PTV, and I'll be presenting for Chayton. He's unable to make it. Let me go over Visum. I'll try to go a little quick because I think we've got about 20 or so minutes maybe, and try to highlight some of the cool things that we've done in Visum this last year. So we've got a few different areas of improvements. We've done a lot of work in dynamic assignment functionalities for traffic engineering. I'll talk about that, SBA. We've done improvements for activity-based modeling integration. We've made improvements for public transport modeling. We've made improvements for bike modeling. That's mostly under the sustainability topic. We also made some improvements for emissions modeling for European customers, which is under sustainability, but I'm not going to talk about that today. And some miscellaneous or additional topics. All right, so first let's talk about dynamic applications. So some of you are probably familiar with the simulation-based assignment that we have, the mesoscopic DTA type modeling with modeling intersection geometry and signal timing in sub-area models or corridor models. So sort of halfway between macro assignment and microscopic simulation in Visum. So we've been making improvements to SBA over the years. We've added improvements for lane modeling in this release. So instead of modeling everything at the link level, now you can model different vehicle types at the lane level. This is especially good for like HOV lanes or like evacuation planning, like Thomas mentioned yesterday. So applications like that. Let's make sure this starts. Let me make sure this starts here. So, so we're in Visum now, and we're doing simulation-based assignment. And so, what we're modeling here in the lower lane or the lower link there is we're going to make the HOV lane only available from 7 o'clock onward, and so only the yellow cars will be able to travel through that. And so, basically, we're adding lane level modeling into SBA. That's a big improvement. Let me go to the next slide. So we made another big improvement for SBA, which is called hybrid assignment. And this is macro meso assignment. And the idea here is to be able to do your macro static assignment models, but in select sub areas of the region, do mesoscopic modeling with intersection detail and signal timing. And so this allows you to use the benefits of macro assignments where they're faster and you need less detail. You don't have to code the whole network with all that detail. But in select areas like on freeway corridors or in downtowns, if you're going to do like cordon pricing or tolling on freeways, you can use that more detailed assignment method. So you get it still fast, but you get the detail when you need it. And there's some nice benefits to this. I mean, first of all, you don't have to code all that detail for the whole network. It's all in one assignment method. So you don't have to do like tricks where you like sub area, run feedback, go back up to the macro. You don't have to do all that kind of stitching it together yourself. And it also allows you to warm start, which means run the static assignments ahead of time and then preload the times into the model. So you can get faster assignments with this procedure as well. So a lot of great improvements, I think, in that department for a simulation-based assignment. And Adam, you had the simulation-based assignment example yesterday, right? Workshop yesterday. So, okay, we've also made some improvements to signal optimization in Visum. It has different routines in it for doing signal optimization in Visum. This is for coordinated corridor signal optimization. It works with RBC now. It's useful if you're, say, doing SBA and you want to update the timings based on the volumes. So it has different various applications. Let's see if we can see. So it's going to optimize on the volumes and the delays, and then as you can see, time the additional signals down the corridor to match better. So that's another feature that was added for kind of traffic engineering applications in Visum. How many people have used these pseudo dynamic volumes? Anybody use that? Okay, so a couple people. So pseudo dynamic volumes, they basically, what they do is they'll let you take a static assignment and a time series of demand and basically generate like a 24 1-hour assignments. So it's a way to kind of hack together a dynamic assignment result, which can be useful for um, for different applications, like if you're going to export volumes to Visum for a sub-area study, you can do it in Visum easier. You could also use it for SBA initial loadings, things like that. What changed was we made improvements to the data structure, so it's easier to use the dynamic data in different contexts. So for matrix estimation, it's been improved. Flow bundles, Visum export, like I mentioned. Kind of a neat example of it was used for station pedestrian modeling by Deutsche Bahn. So they took transit assignments. They're basically doing like pedestrian level assignments inside the stations to make improvements for station modeling, and then extending it with volumes in order to build like kind of pseudo-dynamic assignments inside stations. So that's kind of cool. All right, in the sustainability topic, this is focused mostly on bike modeling. So this has been something we've been working on over the years. We added bike assignments for Portland Metro and others that are specific assignment algorithms for biking, different path generation routines using slope and generalized cost and improvements to bike routing. But what we also needed to do was make improvements to the data import procedures. So we have better OpenStreetMap importers for bike and walk stuff now. So it imports more of the data. It gives you more settings for different types of facilities and types of bike links. It also brings in elevation data with it, so you can basically build bike networks a lot easier. All right, another area of improvements was activity-based models. So for a recap real quick on activity-based models, instead of modeling just trips between locations, activity-based models models people and their travel in the form of tours. So basically it does a synthetic population of all the people in the region, and then it generates tours like from work to home and all the stops along the way. And so it has a lot of benefits for better modeling consistency of travel. So for example, if you leave to go to work by car, you know, you're very, very, very likely to return by car. You're not likely to leave your car at work. So these kinds of consistencies across time and space are better in activity-based models than traditional trip-based models. And so we've basically been making improvements to Visum to support that. So one of the things we've been doing, and I think Guy mentioned this for Atlanta, but I know Alex at ODOT and also in Florida, they're using ActivitySim. This is an open source package for activity-based modeling, and we're basically making it work better with Visum. And so ActivitySim is like a activity-based modeling engine, and it's pretty bare bones in terms of user interface and data management and stuff like that. So it's basically reading different text files and matrix formats, and you have households and persons and things like that. And what we want to do is use Visum to be the interface to manage the data for you, to do visualization for you, to run it and stuff like that. All right, so let me show you some. I'm going to step through this a little faster just because make sure I grab everything here. Oh, okay. All right, so what we've done is basically added data structures in Visum to store households, a list of households, a list of persons. Those are assigned to TAZs. And then after you run the models, you also get all the tours for the persons and you get all the trips for the person. And those are now stored in Visum. And we've also added procedures to run ActivitySim. So it basically, you configure it. I'll show you here in a second. You can configure it in Visum. It'll run the ActivitySim engine and return the results back into Visum. We've also added importer for a population synthesis procedure, which Guy, you mentioned yesterday. And that's a population sim, but it works for others as well. And so the idea is, instead of working hard, this guy looks kind of like Mario, I was noticing the other day. Instead of having Mario working hard on the engine on his own, you know, now you're using Visum as an interface, and it's hiding a lot of this stuff or encapsulating it for you so it's easier to use. What does it look like? So you've got dialogues in Visum in order to specify where the ActivitySim engine is, where to set up the configuration files and some of the parameters. More settings on what to import, what tables to return back. Also, one of the things that activity-based models often do is they often have multiple zone systems. So instead of having just one set of zones, TAZs, for highway traffic, they have sometimes 2 or 3 sets of zones. So they'll have a different zone system for biking and walking. That's very small because the additional granularity is important. for biking and walking. And they'll also do transit stop-to-stop modeling. And so instead of modeling like zones for car travel from zone to zone, they do transit stop to transit stop. And that's also supported now in Visum. And so you can configure that in Visum with native Visum objects. So you can use what we call location objects for the microzones or for locations of travel. You can use the TAZs for the highway travel, and you can use the Visum transit stops for the transit stop skims. And that's configured in the dialogues and stuff. So instead of just working with text files now, you can work in the Visum data structures. Here's the location objects all in the map. Those are the zones where people, because we're moving on towards microsimulation of people and their travel patterns as opposed to aggregate trips. You can trace tours of people in Visum and see the results of their entire day. You can make charts and stuff by time. And then we also and I think Adam, is it later today, Adam, you're going to talk about Publisher? Yeah, I think it's later today. You can also export the results up to Visum Publisher and share those online, 3D animations of the travel patterns too. All right, let's talk a little bit about public transport. One of the things we've done to improve public transport is the processing of input, output, or check-in, check-out data, so like fare card data for major metro systems. Essentially, we've had routines over the years for major transit operators to basically be able to read fare card data that you collect about your region and then compare it against your travel network, basically route the fare card data as best you can across the network in order to then aggregate the results of the fare card data to line data. So basically like a big data engine to process transit fare card and survey data. And we've been making improvements to this over the years. I'm going to skip through a couple of these slides, but basically it's going to try to impute or guess as best it can the routes and stuff for the fare cards, because people check in and check out of these systems, but they don't know where they transfer and things like that. And so the software basically routes them and compares them and does stuff like that. All right, so it's added different checks, basically plausibility checks, to make sure that it does a better job of building the fare card data for you. It's going to check the locations, the timestamps, and compare those in order to then choose the best routes. And we've also made the procedure a lot faster, 150 times faster. And I didn't use the procedure in the past, but certainly an 8-hour runtime seems kind of unrealistic. So now it's a much more realistic runtime for typical fare transit operators. We also made another improvement in the transit department, which was being able to do the transit stop-to-stop skims that I mentioned earlier. So before, the tricks that you would do is you would have a zone system and you'd have your transit stops, and you'd take your Visum file and you'd export it, and you'd delete all the transits or all the TAZs, and you'd take all the transit stops and convert those into TAZs, and then you'd rebuild everything, and then you'd run those procedures. But now it natively supports those different types of skims, basically zone level skims and transit stop skims in Visum. And so this just makes it a lot easier for you. And so this little video just shows you how you basically can take the transit stops, and there's a new generate zones function that will, create the zone system for you automatically. I'm going to skip it because it's not that exciting, but to see. We've also made improvements to the Google Transit importer. So we now read the shape points in, we read the calendars, we've made it faster, basically just continually, adding more support for open data formats and speeding them up, and, because everybody's using this kind of data now, and we want to make sure to be able to continually use it and do a great job with it. Another neat highlight that I want to make sure to, thing that I want to highlight is we've also made improvements to the skimming procedures, so they're a lot faster than they were before. The PRT, the highway assignment skims are like 50% faster, and the reason for that is because basically the path data has to be stored in compressed form, because it's a lot of data. And so when we compress it, you can do different tricks, right? Basically to manage your data. You can store it when you're running the assignments, you can compress it so that it's optimized for reading, or you can optimize it for writing. And what we did was basically made some improvements to the way that we uncompress the paths in order to generate the skim information. And so it's much faster now than it was, which is, I think, really great. And those kind of same tricks we've used for different other procedures as well. So the incremental assignment's been sped up using some path decompression improvement techniques. Also filterings, the transit assignment's a bit faster, and the transit assignment skimming procedures are also faster. So I don't know, and if you didn't see the presentation last year, we also made a bunch of big improvements to the classic equilibrium assignment procedures in Visum that are much, much faster than they were before. So if you're not using Visum 2022, let's talk at the break, because that's also really impressive too. But that's not in this 2023 release, so I didn't have slides on it. More cool stuff. Lucas, you kind of already mentioned this. Basically, the web mapping interface is much more intuitive now. It has like a wizard so that you can configure your use of the maps based on the service. So instead of having to hard code the description of the service, you put in the service endpoint, and then you have a wizard that kind of helps you configure it. We've also added the ability to so some little stuff now. We've added the ability to like rotate labels and make nicer maps, clean that kind of stuff up. We've also made improvements to the legends. That's what this video is going to show you. And just kind of making it more likely that you'll use this for, your maps that you're going to use for production. I'm going to sneeze, but maybe not. We'll see. So here you'll see that basically we can improve the legends, tighten them up and edit them and stuff like that. Just, basic stuff, but, really helpful, if you work on these and you want to save these and reuse them. More improvements also, grouping of procedure sequences. So Deutsche Bahn, German rail is one of our big customers, and they wanted improvements to procedure sequences because they have a lot of procedures. You can group them and make subgroups and name them. And then also for user-defined attributes, you can create basically folders and store those, so more data management stuff. The last thing is the Python installation, which is the same thing Lucas basically said, is now the Visum basically takes more control over the Python installation that it provides and embeds it so that it's less likely to, it's not going to conflict and cause problems with the other Python installations. Because if you have lots of Python installations, it's a big mess. ArcGIS and Visum and maybe a separate Python or something. So you can still point Visum to use external Pythons if you need to, and you can also configure them. So that's a nice improvement as well.